Okay. So the first question is problem 340. The question asks to find the average value of pointing vector. Let's write average value of pointing vector. For sunlight arriving at the top of Earth's atmosphere, they gave the distance, let's call it D, equals to 1.5 times 10 to the 11 meter, the distance between Sun and Earth. Okay. And this value is 1.4 kilowatts per meter square. So in the first question, it asks to find average radiation pressure. Exerted on a metal surface. Okay, so the metal surface is important because if we have a fully reflected surface, reflecting surface, then we will use and actually the same formula, but we will multiply it with 2. So please be careful in the exam if it says metal or absorbing or anything else. And in part B, it asks to approximate average radiation pressure on Sun's surface. Okay, so let's start with A. We know that the average radiation pressure, this is time average sign, you know already. Okay, I will try to make radiation pressure with this P. So if I don't, please don't get confused, and you can also warn me. Will be 2 times average pointing vector, which is also intensity over C. So let's write it this way. Also there's 2 in here. Okay, so this 2 is what I mentioned a minute ago. If it's reflecting surface, we will multiply with 2. Okay, so our value will be 2 times 1.4 times 10 to 3, because it gave kilowatts over 3 times 10 to 8 meter per square, and this is watts over meter square. Will be 9 times 10 to minus 6 Newton per meter square. So this is the answer. It's easy, but please be careful if it asks for average or instantaneous. It wouldn't be instantaneous, most probably, but still be careful. In B, it asks to approximate the average radiation pressure. So we know that the intensity will be changing. Let's write in this way, 1 over d square, and we will go to inverse. What do I mean? I sun r square over d square would be I earth, right? Because the intensity will decrease with d square, but I don't have I sun. The question asks for this, but I have this I earth, then I will use I earth. I will do this, d square over r square will be equal to I sun, right? Now I will substitute the numbers. 1.5. For radius, be careful. We are given the diameter, and our diameter is 1.4 times 10 to 9 meter. So our radius will be 0.7 times 10 to 9 meter. Okay, So 10 to 11 meter, this was the distance square times 1.3 times 10 to 3 over 0.7 times 10 square. Okay, so we don't have this. I get confused. We have this, right? This was the average pointing vector on Earth's surface. So by using this, we can calculate the sun's surface, and this will give 6.42 10 to, let's move this a little bit, times 10 to 7 watt per meter square. So I will take this value and substitute back to the average radiation pressure formula. S over C. But I know that S is also equal to I. Average of S is equal to I. So it will give me 6.42 times 10 to 7 over 3 times 10 to 8 meter per second. And this is watts per meter square. And this will give me 0.21 Newton per meter square. In the example, please be careful about the units we were given. Can you explain this formula for B? Actually, it's not exactly a formula. Your book doesn't also give it, and I don't know where they find. But normally, as I said, the irradiance will decrease. Actually, inverse square law. You would remember it from Kepler's law and electric field laws, etc. The irradiance will decrease, will change with the square of distance. But in here they use the radius as well. I don't know why do they doing that way, but when I do the research, I found every source uses the R square. It may be because of the area of sun, because we have this point. So this is the distance, this is R, this is Earth. We know this irradiance, and we will go back to this part. So probably from here, there's a geometrical background of this R square. But for D square, as I said, the irradiance already changes with D square. So this is inverse square law. Inverse square law. In fact, there's a chapter about it, and if I can find out somehow, I will put it in the videos, okay, in the supplementary videos. Okay, so are there any other questions that I cannot answer properly? Okay, no. So in the second question, we have a parabolic antenna. A parabolic, that's right. Parabolic antenna with diameter of 2 meters, and it transmits 100 kilowatts pulses of energy. These pulses are 500, let's write in this way, pulse per second, and the duration of each pulse is 2 microseconds. So it asks for the reaction force. Reaction force of the antenna. We know that action reaction, F action will be equal to F reaction. So if our antenna is hit by 100 kilowatt energy pulses, actually it transmits, so our antenna will not be hit, it will hit something. But anyway, the force will be equal the hit force and the transmittance force will be equal, then we will say force is equal A times average radiation pressure. Actually, this is just F over A is equal pressure formula. And we know that radiation pressure is equal to S over C. And for S equals I, we will use P over A times, times 500 pulses per 1 second, right? And each will last for 2 microseconds, which is 10 to minus 6 seconds over, so there's no over, sorry. And this is the power. If I substitute everything, the power, the area, etc., I will find I equals S average equals 100 times 10 to 3 watts times 500 pulses per second times, actually let's write area in here. They will cancel out, so I will not find the area, times 2 times 10 to minus 6 seconds. The formula says that F is equal 8 times, I'm using this one. Actually, I'm substituting this to here, S over C. So if I substitute in here, the A's will cancel, you can see it. So my value will be 10 times 3 watts times 500 pulses per second times 2 times 10 to minus 6, which will give me also times C, sorry, 1 over C. Sorry about it. So our formula is this. I substituted this in here. 3 times 10 to 8 meter per square, and the answer will be 3.33 times 10 to minus 7 newtons. Okay, so you need to know this force and radiation pressure formula. This is actually force and pressure that we saw in Physics 109 course. As I said, force over area will give the pressure, and I substituted pressure as S over C. I found S, and then again I substituted everything in the force formula, and I substituted the numbers, and I calculated this. Okay, so the other question. Any questions for this one? Okay. So in this question, this is an easy question. We are given a wavelength lambda equals to 550 nanometers. This wave propagates inside water. This is lambda air, and this will be lambda water, right? So and water is given as 1.32, and the question asks for the wavelength in water. We know that velocity is equal to C over N, and velocity is lambda prime nu, and C is equal to lambda nu. So this lambda and this lambda are different, be careful about it, but this nu and this nu are the same. So frequency doesn't change when the electromagnetic wave in the matter, only the wavelength changes, be careful about it. So I can just cancel the nu's in this equation. I will say lambda prime or lambda water, let's say, nu is equal lambda 0 nu over. And I just substitute everything in this formula. Okay. So these are the same. Then 500 nanometers per 1.33 will give me lambda water. Then lambda water will be 413 nanometers. Okay. So be careful that, again, I'm repeating, the lambda changes in bulk matter, but the frequency doesn't change. Wavelength changes, frequency does not change. Okay, so this recitation feels like it will last shorter than I expected. Are there any questions? Also, nobody sends me questions in email. So if you have questions, you can send them as well. For the exam, you can send your questions by tomorrow morning, so I can record videos as well. Just keep it in mind. Okay, so I have question 450 from Hecht again. The question says that we have an irradiance, let's write in this way, equals to 200 watts per meter square. This comes perpendicular on a watt of ethanol. So we have some ethanol in here, and we have light striking through it. The question asks for the irradiance at the bottom. Ethanol. And the refractive index of ethanol is given as 1.36, and the outside medium is air. This is so we will use Fresnel equations. Since it asks for the bottom irradiance, we need to find the transmittance, because the beam transmits through the ethanol, and some of its power, its irradiance, will decrease. So I will use the transmittance formula. T perpendicular is equal for an ethanol and air over an air plus an ethanol square, and it will be 4 times 1.36 times 1 over plus 1 square, and this will give me 0.977. Now I found the transmittance. I know that transmittance is equal to I transmittance over I incidence, because since some of the light will change, will be lost, I will use this ratio to find the transmittance. Transmittance is a ratio. I know that transmittance is about 0.98, and IT is asked in the question, and I incidence is given as 200 watts per meter square in here. So I transmittance will be equal to 0.98 times 200, 1.95 will be our I transmittance. Of course, this is watt per meter square. Okay, so I rounded the numbers up. This was 0.97 but I wrote 9/8, so this will probably be something like this. Okay. Okay, anyway, just be careful when you're rounding up, but the important thing is you need to know this and this. Okay. Did we do some calculation mistake? This is too little. Maybe yes. Why don't you warn me? Are you listening, guys?
Yes, hocam.
Okay, anyway. We had one more problem. I can't find my problem. So the next question is question 460. The question asks us to use Fresnel equations to prove polarization angle will be equal to 1 over 2 pi minus transmittance angle. I know that for our parallel or our perpendicular is equal to 0, my theta incidence will be equal to theta polarization. This is polarization angle. Then by using this information, okay, let's go this part back. For this equality, theta incidence, equals theta polarization will be 1 over 2 pi minus theta. Transmittance is given, so they ask us to prove this, right? I know that our parallel is equal to tangent theta incidence minus theta t over tangent theta incidence minus theta t will be 0 to validify this equality. Then from here we cannot find it in your book. The book takes 1 over of all these quantities, so I will do the same to find 1 over r parallel will be equal to tangent theta incidence plus theta t. I don't think Ihorja will ask a proof question or a derivation question, but still I'm solving this problem. Theta t equals 1 over 0, because otherwise I need to find something like 0 over 1, and from there I can't go anywhere. So this will give tangent theta incidence plus theta transmittance to infinity. At this point, we need to consider for what value of tangent we have infinity. And the answer will be pi over 2, of course. Then I will say tangent and theta incidence plus theta transmittance will be pi over 2, as theta incidence is equal to theta transmittance. Okay, this can't be pi over 2. It can be pi over 2. Okay. Then I know that theta incidence is equal to theta polarization. And if just if this is equal to theta transmittance, I'm going back to this, carrying this one here. My theta polarization will be pi over 2 minus theta transmittance. Okay, so these were the questions. I think there was one more question, but I didn't solve it. And it lasts very short because the questions were very easy. Do you have any questions about any of the questions, or in general, do you have any question about economics? Okay, then I will start the recording, stop the recording.